Hey guys, Mr. Riz here to help you guys out with the 10.2. Am I sharing this? Okay, there we go. I don't know where my face went. Let me make sure. Okay, there we go. All right, 10.2 notes. We're going to be multiplying matrices here. So what does it mean to multiply a matrix by another matrix? And our goal is to be able to make sure we can find the product of two matrices. So let's start with this example here. And this will help us understand how we multiply each matrix C. So if a teacher assigns final grades based on a weighted system, the students are graded on unit assessments, a semester project, and a final exam, which each weigh differently. So the matrix below represents the weight for each kind of work and the grades of the two students. What are the final grade for each student? So we can see here is the weight matrix, see where the unit grades are 50%, the project grade is 30%, and the final grade is 20%. And then right here we can see Oscar, who had a 90 on his unit, a 95 on his project, and a 75 on his final. And Reagan, who had a 80 on her unit, 70 on her project, and 85 on her final. So if we were going to just find the grades here, if I was going to figure out Oscar's, what we would do is we would take, okay, he got unit grade 90%, so I'd take 90, we times it by 0.5. All right, and let's see, 90, that's 45. And then we would do his project grade, which is a 95 times the 0.30. And I'm going to have to grab a calculator for that. 95 times 0.3, that is 28.5. And then his final grade of a 75, we'll times it by 0.2 or 0.20. 75 times 0.20 is 15. And we would go through and add them up together, and we'd say, okay, 15 plus 28.5 plus 45, he has an 88.5. Now Reagan here, we would do the same thing. We'd take the unit, they got an 80%, we're going to times it by 0.5, which is 40. All right, we'll take the project, they got a 70, we'll times it by 0.30. 70 times 0.30 is at 2.21. And then at 85 times the 0.20 for the final, 85 times 0.20, 17. And we'd add those together, 40 plus 21 plus 17, we get a total of 78. So what we could do here is we could make a matrix of their final grades, right? We could say like a final grade equals, well, Oscar's grade would just be 88.5, and then Reagan's grade is 78. So what we did, though, mathematically speaking, is we took this weighted and we times it by the grades, and that's how we got the final. A couple things to notice here with the steps that we did. We took each element here. We took the first element here, multiplied by the first. So we're looking at the row here. We took the first element in the row, times it by the first element in the first column. Then the second element with the second. Then the third with the third. And then we repeated the step for the second column. First element in the row, first element in the column. Second element in the row, second element in the column. Third element in the row, third element in the column. And then we got our corresponding answer. Okay, so let's take a look at what this means. You know, how do we abstract that to just any matrix C here? So when we multiply another matrix by a matrix, we use what's known as like the dot products of the row. And so this is what it means here. If we're going to multiply this matrix here by this matrix, that, you know, these are two matrices we couldn't add together, but we can multiply them. We're going to multiply each row by the column. So we're going to take row 1, which is 1, 2, 3, and we're going to multiply it by the first column in the second matrix. So 1 times 7, we're going to multiply 2 times 9, and 3 times 11, and add that together to get 58. Then we will repeat that same row with the second column. So 1 by 8, 2 by 10, 3 by 12, we add those together to get 64. Once we get that done, we're now going to go through the second row and do it again with the first column. So we'll do 4 times 7, 5 times 9, 6 times 11 to get that number there. And then we got to do the last second row with the second column, 4 times 8, 5 times 10, 6 times 12, and get that number there. And that's how we get a completed matrix. So the first goal is, can we go through and multiply these matrices together? Okay. So one thing we want to look at here is that we need to make sure that our rows and columns always match up. So we have an example here that this matrix C is a 2 by 3. It has 2 rows with 3 columns. Okay. If we were going to try to multiply that, we would have to make sure the next matrix C has at least 3 rows. All right. So one thing we can look here is that there's going to be a trick. If we ever want to multiply the matrix C, we can actually figure out the dimensions of the answer. If we look at this column here, this is a 1 by 3 matrix here, and this one is a 3 by 4 matrix. 1 row, 3 columns, 3 rows, 4 columns. So we know we can multiply them because they match up with the columns compared to the rows. And the way to write this out is nice because if these two numbers next to each other match, it's going to work out. Here's the other cool thing is that the numbers at the end, the 1 and the 4, actually give you the dimensions of the answer. This is a 1 by 4 matrix here. So we can kind of predict what our answer matrix is going to look like based off of the setup of the problem. Okay. So we can go through and see this one here. We have a 1 by 3 matrices. It's good because a 1 times 3, or the 3 and 3 match up. Our answer is going to be a 1 by 1 matrix, which is just one answer here. All right, this problem here is a 3 by 1, and this is a 1 by 3, which we can do because they match up, but our answer is going to be a 3 by 3 matrix in the end. All right, so let's check a couple of things out. Let's multiply some matrices here and make sure we can do that. All right, so here we got some square matrices. These are nice because these are 2 by 2 and 2 by 2. All right, so we can multiply 2 by 2 because they both end with 2. And then at the end, our answer is going to be a 2 by 2. So let's check out some answers. Let's see if some properties are the same. What's A times B? All right, so A times B. Maybe we'll write this out the long way, and then we'll simplify this. All right, first row here, first column. So we got to do -2 times -1, and that'd be 2. And then 1 times 0, be 0. All right, next we're going to go first row, second column here. -2 times -5 is 10. 1 times 4 is 4. All right. Next, what we could do here is the second row, first column. -1 times -1 is 1. 0 times 0 is 0. And second row, second column, to get this last one here, -1 times -5 is 5. 0 times 4 is 0. All right, so what does that simplify? 2 plus 0 is 2. 10 plus 4 is 14. 1 plus 0 is 1. 5 plus 0 is 5. So we got a 2, 14, 1, 5 matrix. Let's see what that is if we did B times A. All right, so you might have to switch gears, or you might have to, maybe rewrite A over here, and that's what I'm going to do here. -2, 1, -1, 0. All right, so if I was going to do B times A, maybe we'll put the answer here too, just to kind of simplify things. All right, B times A, we got to do -1 times -2, which is 2. And then -5 times -1. All right, that would be, -5 times -1. That would be 5. And so 2 plus 5, that's 7, first number. All right, next, -1 times 1 is -1. -5 times 0 is 0. If we add those together, that's -1. All right, now second row, first column. 0 times -2 is 0. 4 times -1 is -4. 0 plus -4 is -4. All right, second row, second column, 0 times 1 is 0. 4 times 0 is 0. 0 plus 0 is 0. So if we look at these two matrices here, I forgot that probably was too close. A times B is not the same thing as B times A. So that's one of the things that's where we know A plus B is B times, and same thing with any multiplying. 3 times 2 is the same as 2 times 3, but that does not work with matrices. So we have to be careful with those things. All right, what about the multiplication property of square matrices here? What if we want to make this a little bit more complicated? Is A times A plus B the same thing as A times A plus B? Okay, so let's go through. We're going to have to do some work here. We're going to have to see, okay, take this problem once. All right, so we're going to do matrix A, which is -2, 1, -1, 0, and we're going to multiply it by A plus B. So let's add these together first because rule says we have to add them together. Okay. One second here. All right, sorry about that. Let's go through this. Now what we need to do is we got to add the two matrices together. Let's figure out what A plus B is. All right, A plus B, -2 plus -1 is -3. 1 plus -5 is, let's see, that would be -4. -1 plus 0 is -1. 0 plus 4 is 4. Okay, now let's multiply these two matrices together. So first row, first column. So -2 times -3 is 6. 1 times -1 is -1. And so that means our answer is going to be 5. All right, first row, second column. -2 times -4 is 8. 1 times 4 is 4. 8 plus 4 is 12. Okay, then we got -1 times -1 is 1. For second row, oh wait, actually I got that backwards. -1 times -3 is 3. 0 times -1 is 0. All right, and then second row, that'd be 3. And then second row, second column, -1 times -4 is 4. 0 times 4 is 0. Add them together, that's 4. Okay, so this answer right here is A times A plus B. We're going to see is that the same thing as if we did that. All right, so now to do this problem, what we got to do is two things. We got to do A times A, then we got to do A times B, and then we're going to add those two matrices together. So let's do A times A. -2, 1, -1, 0. We're going to multiply that by itself. -2, 1, -1, 0. We don't just square all the numbers. Okay, so let's see. -2 times -2 is 4. 1 times -1 is -1. And so we would have a 3 here in our answer. All right, next, second column here. -2 times 1 is -2. 1 times 0 is 0. -2 plus 0 is -2. All right, now second row, first column. -1 times -2 is 2. 0 times -1 is 0. And so we get a 2 here. All right, and then second row, second column. -1 times 1 is -1. 0 times 0 is 0. -1 plus 0 is -1. All right, so that's A times A. All right, let's do A times B. So -2, 1, -1, 0, and we would have B is -1, -5, 0, 4. All right, -2 times -1 is 2. 1 times 0 is 0. All right, next, -2 times, oh, we should probably get that answer. That'd be 2. All right, -1 times -5 is 10. 1 times 4 is 4, and that would be 14. All right, now second row, first column here. -1 times -1 is 1. 0 times 0 is 0. Okay, and that would be 1. And then let's see, second row, second column. -1 times -5 is 5. 0 times 4 is 0. 5 plus 0 is 5. Okay, so now let's see, what is AA plus AB? So we're going to take our answer from A, which was 3, -2, 2, -1, and we're going to add it to AB, which was 2, 14, 1, 5. All right, 3 plus 2, that'd be 5. -2 plus 14, that's 12. 2 plus 1 is 3. Negative 1 plus 5 is 4. All right, so let's look at these two answers here. Holy cow, look at that. The matrix A here is the same as that matrix there. So the one thing that works, which is weird, is that the distributive property works, which is weird to think. Like the commutative property, A times B is not the same thing as B times A, but we can distribute matrices and that property would work. Okay, last thing that we're going to do, and we're going to have to kind of pause this here because I got another class. Let's see if we can do this together. Is A times B times C, is that the same thing as A times B times C? Okay, so let's see. Now I'm going to have to pause this video. We'll start this again here in a second. You'll see a jump, and that'd be it. All right, let's keep going with this one here. Sorry about the pause and the break of the video. Just had to stop what I was doing. We'll keep this going here. So this next problem here, we're going to see if does AB times C equal the same thing as A times BC. So what we got to do first in this one problem is we're going to do A times B. All right, so we'll figure out what that is, AB here. All right, so first row, first column. So 3 times negative 2 is negative 6. 0 times 3 is 0. All right, and so that's going to be 6 or negative 6. All right, and then 3 times 1 is 3. 0 times negative 4 is 0, and that would be 3. Okay. All right, next. Negative 1 times negative 2 is positive 2. Negative 2 times 3 is negative 6. Negative 2 minus 6 is negative 4. All right, and then we got negative 1 times 1 is negative 1. Negative 2 times negative 4 is 8, and that would be 7, right? Negative 1, 8, yeah, it would be 7. Okay, so this is AB. What we need to do next is to multiply this by C. All right, and so 6, 2, 4, 8. All right, so first row, first column. So we got negative 6 times 6, that's negative 36. 3 times 4 is 12. All right, negative 36 plus 12, that would be a negative 24. All right, then we got negative 6 times 2 is negative 12. Wait, did I do that right? Oh, I didn't. No, I messed up. Wait, no, I did 3 times. Oh, and then 3 times 8 is 24. Add them together, that'd be 12. Okay. Next, we got to do negative 4 times 6 is negative 24. 7 times 4 is 28. And that would be a positive 4. And then negative 4 times 2 is negative 8. 7 times 8 is 56. Add them together, that would be 48. Okay, so this is AB times C. All right, now over here, let's do A times BC. So let's first figure out what BC is. B times C. So, all right, we got B, first row, first column. So we got negative 2 times 6 is negative 12. 1 times 4 is 4. If we add those together, that would be negative 8. All right, and then negative 2 times 2 is negative 4. 1 times 8 is 8. That would be 4. All right, now first row, first column, or yeah, first row, first, or second column, first row. 3 times 6 is 18. Negative 4 times 4 is negative 16. Add them together, that would be 2. 3 times 2 is 6. Negative 4 times 8 is negative 32. If we add those together, that'd be a negative 26. Yeah. All right, so there's BC. What we got to do now is to take A and times it by BC. So we're going to take A, which is our 3, 0, negative 1, negative 2. We're going to times it by negative 8, 4, 2, negative 26. All right. So 3 times negative 8 is a negative 24. 0 times 2 is 0. So I'm just going to put the answer below here. That's negative 24. All right. 3 times 4 is 12. 0 times 26, that's 0 as well. We add that together, we get 12. All right, next, negative 1 times negative 8 is 8. Negative 2 times positive 2 is negative 4. If we add them together, that'd be 4. And negative 1 times 4 is negative 4. Negative 2 times a positive, or negative 26 would be a positive 52. Negative 4 plus 52 would be 48. And hey, if we look at this answer that we did here, when we did AB times C, we got the exact same thing as A times B times C. So it works with the multiplication or the property. It doesn't matter what order we add them or multiply. So we've got multiple things. We can go in either order. We just can't switch the order around. All right, last thing we're going to check here is, does A plus B times C equal AC? So you might think, hey, we know that A times B plus C, we could distribute and get AB plus AC, but what if we have C at the end here? Will that make a difference? All right, so you know what? We got to go back up, or we can look here. I'm going to have to write them down. I'm going to pause, so I'm going to write all these down here. Okay, so first let's do A plus B. So A plus B, all we got to do is match up corresponding elements. So 3 plus negative 2, that'd be 1. 0 plus 1 is 1. 1 plus 3 is 4. Negative 2 plus 4 is 2. So there's A plus B. Let's times that by C. 6, 2, 4, 8. All right, so let's see. Just, really practicing our multiplication. First row, first column. All right, 1 times 6 is 6. 1 times 4 is 4. 6 plus 4 is 10. All right, next, first row, second column. 1 times 2 is 2. 1 times 8 is 8. 2 plus 8 is 10. All right, now, second row, first column. 4 times 6 is 24. 2 times 4 is 8. Add them together, that's 32. And next, 4 times 2 is 8. 2 times 8 is 16. If we add those together, that's 24. All right, so this is A plus B, then multiplied by C. All right, we're going to see if that's the same thing as AC plus AB. So let's do AC over here. AC. We're going to multiply A times C. First row, first column. So 3 times 6 is 18, plus 0 times 4 is 0. That'd be 18. All right, next. 3 times 2 is 6. 0 times 8 is 0. That'd be 6. All right. Next, let's go through here and do the first row, first column. 1 times 6 is 6. Negative 2 times 4 is negative 8. 6 plus negative 8 is negative 2. And last one, 1 times 2 is 2. Negative 2 times 8 is negative 16. Add them together, that'd be negative 14. So this is AC. Next, let's figure out BC. Alrighty, so first row, first column. All right, negative 2 times 6. Negative 2 times 6 is negative 12. 1 times 4 is 4. Add them together, that'd be negative 8. All right, next. Negative 2 times 2 is negative 4. 1 times 8 is 8. Add them together, that'd be 4. All right, next. Second row, first column. 3 times 6 is 18. 4 times 4 is 16. Add them together, that would be 34. All right, and then last one here. 3 times 2 is 6. 4 times 8 is 32. If we add those two together, that would be 38. Okay, so here's AC, here's BC. If we add these two together, so whatever AC plus BC is, 18 plus negative 8 would be 10. 6 plus 4 is 10. Negative 2 times or plus 34 is 32. Negative 14 plus 38, that would be 24. And hey, we get the exact same answer here. So the distributive property works whether it's in front or whether it's behind, which is nice. Okay, so those are the properties that we just went over here. When we multiply two things together, we use first row with first column, first row with second column, second row with first column, second row with second column, so forth. And that will go through. Now, if we have this nice identity line here, that actually gets the exact same answer. So we have a nice diagonal line going all the way across, we'd get the exact same thing if we multiply. All right, guys, so this wraps up the multiplication. I'll see you guys next when we start talking about inverses. See you later. Have a good one.